Hello children, here we are doing a few numericals on resistivity and resistance. Now there are a few important questions I would like to discuss. Number one is, what will be the resistance of wire if it is stretched to triple its length, and what will take its initial resistance 5 ohm, what will be the change in its resistivity also. Both the things you have to find out. Now suppose we are stretching anything. Then if I stretch something, what happens? If its length increases, then you take a rubber band and you pull. Then what will happen? Its length will increase, but its thickness will decrease. This is mathematical because the volume will remain constant. So the volume is product of area of cross section into length. So if length will increase, obviously the product has to remain the same, so the area will decrease. That's mathematical. So here I have drawn the same thing. See what happens? There is a wire of length L and it is stretched, so 3 times. So if it is stretched 3 times, so if its initial area of cross section was a meter square, now its new area of cross section, this is new area of cross section, will become a by 3. So let us compare now. The old resistance is equal to rho L by A, obviously, and the new resistance will be rho, the length here is 3L, divided by the area of cross section will be A by 3, isn't it? Area new, or that means 1/3 of the initial area. Now what will happen? So resistance new, if you see rho 3L by A by 3, so the 3 goes up, so into 3 by A, so resistance new is equal to 3 through 9 rho L by A. Obviously this rho L by A is equal to R, so resistance new will be equal to 9 times R, 9 times R, but the value of R is given as 5. So what will happen? Let us see. The value will be how much? 3 square, that is 9 times. That means 9 5s are 45 ohms. That will be the new resistance. That means the resistance increased 3 times because of the increase in length, and another 3 times because of the decrease in the thickness. So total 3 into 3, 9 times of the original resistance. Now what you must be wondering, the rho remains the same both the places, because as I said, the resistivity does not change. So what will happen to the resistivity? Here you have to say no, nothing happens, no change, but resistance will change. Now just to sum it up, now they will ask you simply, there is a trick. If a wire is stretched to double its length, 2 times, then the resistance will become 2 square times. That means I have to multiply the original resistance by 4. If it is increased to 9 times, then the resistance will increase 9 square, 81 times. If it is 5 times the resistance, if a wire is stretched to 5 times the length, then the resistance will become 5 square times. So 5 square is what? 25 times. So we can derive a formula actually, and that is why for the derivation of the formula, I have intentionally given a question where we can get a formula. What will be the change in the resistance and resistivity if a wire is stretched to n times? So suppose the original length is L, so area of cross section is A. Now the new length will be n times the old length. So when you are stretching it, the length increases n times, then the area of cross section decreases by n times. So now simple, R is equal to rho L by A, and R new is equal to rho NL, that is the length here, by area of cross section, so area by n goes on the top, so Rn is what? N into n is n square rho L by A, so Rn is equal to n square into this original resistance. So we get a formula, so you can directly write the answer sometimes. What will happen to a wire whose resistance is 6 ohm if it is stretched 5 times? So just put 5 square, that is how much? 25. 25 into the original resistance is how much? 6. 25 into 6, that is 150 ohms. Secondly children, as I was discussing, resistance is inversely proportional to conductance. So normally conductance is what? Resistance is the resistance is the property of a conductor which which opposes the flow of current, and conductance is the property of a conductor by the ease which current can flow through it, and conductance unit is Siemens. Remember this, conductance unit is Siemens. So conductivity is Siemens meter. So that is there. So, and conductance unit, since resistance units we symbolize ohm, therefore conductance we symbolize mho, MHO. So that you have to remember. Thank you. Have a nice day.